Okay, we are starting chapter 5, and 5-1 is about ratios. This is a review of last year, so 5-1, it should sound familiar. Example 1, we need to write the ratios in simplest form. 15 bikes to 9 skateboards. That means 15 bikes to 9 skateboards. Remember, we can write ratios as fractions. So I'm going to write it 15 bikes over 9 skateboards. In order to write it in simplest form, I need to see if there's any factors in common. Between a 15 and a 9, there is a common factor of 3. So I'm going to divide it by 3 over 3. And I get 5 bikes per 3 skateboards. And 5 to 3, that can't be simplified anymore. So that is our ratio. That is our answer. In example 2, now we're working with measurements, which means we're going to have to change units. So 3 yards to, I'm going to write as a fraction, to 12 feet. In order to compare them, I need to have the same. Yards and feet are different. So I'm going to change yards into feet. And there's 3 feet in 1 yard. So 3 yards would be 9 feet. 3 feet, and 3 feet, that makes 9 feet. So now that ratio becomes 9 feet to 12 feet. 9 and 12 have a common factor. Again, this common factor is 3. So now I have 3 feet to 4 feet. And that is our ratio in simplest form. So because my two quantities were both measurements, yards and feet, I had to find one in common. I could have changed feet into yards, and I would have had 3 yards to 12 feet. Okay, there's 3 feet in a yard, so that means 12 feet is 4 yards. And then I'd have 3 yards to 4 yards. It's the same. The ratio is just 3 to 4, or written as a fraction 3 to 4. Okay, it's the same thing. What's important is changing the units. In example 1, comparing bikes to skateboards, I can't turn bikes into skateboards. There's no unit I can use, so we just keep it as bikes to skateboards and then just simplify the fraction. But yards to feet, I do need to change them so that they're the same units. Let's try another one. 2 feet to 9 inches. So 2 feet to 9 inches. There's 12 inches in 1 foot. So in 2 feet, multiplying it by 2, there's 24 inches. So now my ratio becomes 24 inches to 9 inches. Again, oh my goodness, they all have the same common factor of 3. So now I have 8 inches to 3 inches. 8 and 3 don't have any factors in common, so that is my answer, 8 to 3. In example 3, you have to decide whether or not the fractions, the ratios, are equivalent. So 3/27, I'm going to simplify it. There's a common factor of 3, so I'm going to divide it by 3 over 3, and I get 1/9. 2/18, there's a common factor of 2, and that gets me 1/9. 1/9, 1/9, they simplify to the same fraction. That means they are equivalent. The answer is yes. We could replace this and sign with an equal sign, and that would also be something you could answer in the box. Here's another one, 12/15 and 27/36. So 12/15, there's a common factor of 3. 12 divided by 3 is 4. 15 divided by 3 is 5. 27/36, there's a common factor of 9. 27 divided by 9 is 3. 36 divided by 9 is 4. 3/4 and 4/5 are not equal, So are they equivalent, 12/15 and 24/36? No, they are not equivalent. Okay, it's your turn. Please do 2 through 10 even. That's 2, 4, 6, 8, and 10. Write the answers in the Google form and bring your work to class tomorrow. Thanks everyone. We'll keep going with ratios tomorrow. Good night.